A reminder that the is being recorded following NOAA privacy guidelines in order to allow those that aren't able to attend to view the content later. By joining and participating in the meeting, your consent is being given to the recording. If you need additional information, the Privacy Act statement should be linked in the calendar invite. So for this week, we have Peter Speck, newly of NWS Albany, and he's going to be talking to us about an not so elevated supercell from Eastern Iowa that moved through the Chicago area last year in April. So if you're ready, Peter, go ahead and take it away.
All right, thanks, Jenny. Before I get going here, I just want to acknowledge my coworkers back in Davenport for their immense help on this presentation. First off, Dave Cousins, and then lastly, Matt Friedlein, who is also on this call, who will be speaking here at the end of the presentation. This was one of the more memorable severe events at my time in Davenport. A lot of lessons learned, a lot of humbling moments from this, and what better way to learn and from those humbling moments than to do a presentation. I mean, a lot of research just to see what happened, what could have been done better, and a lot of takeaways. You're going to see a lot of that here through this presentation. So goals of this presentation, a couple of things I wanted to talk about, the significance of this prolonged supercell. You know, we get so many supercells across the area every year. So what set this one apart from every other one that we had? I also want us to think about the challenge in recognizing a low confidence yet high impact signal, because believe it or not, some of these things can happen. A lot of the things that we don't expect, like any preconceived notions or assumptions, sometimes they may not happen. Sometimes things may happen that you don't think may happen, that are maybe a small chance. So I want us to kind of think about this as we go through the presentation. That ties into expecting the traditionally unexpected. In this case, the elevated supercells can at times produce severe winds, and they could be significant. And you'll see the magnitude of that through the storm as we go about several of the slides here. And then lastly, Matt's going to jump in at the end and talk about some messaging and warning takeaways that other offices and folks can use from this event that we learned. Before I really jump into this, I just want to highlight the time period of which the supercell took place in. So this happened on April 4th, 2023. And this was all part of a pretty expansive severe weather outbreak that happened across the area. So this began all the way back around March 31st. During that time period, the Davenport County warning area had numerous tornadoes across the area. And then that tied in with another severe weather outbreak that happened on April 4th, April 5th, where we had more supercells, including the morning supercell of April 4th. But this was all part of the billion-dollar weather disasters of 2023. So it just goes to show and give you guys a scope of where this event falls. So what happened on the morning of April 4th? To get everything kind of set up in a background here. So pretty expansive system was moving across the area, pretty potent shortwave trough across the central U.S., which was bringing a lot of warmth, lift, and moisture across the Midwest, across Mississippi River Valley. This led to numerous thunderstorms developing during the morning of April 4th, including one lone supercell across south central Iowa, which eventually transitioned into a family of supercells as it moved into the Chicago metro, northern Illinois, northeast Illinois. This was an early morning event as well when it started out. It started out around 7 a.m. across south central Iowa and traversed eastern Iowa and northwest Illinois, generally around the 8 to 10 a.m. timeframe. And then as time went on during the morning and early afternoon, that cell transitioned into more northern Illinois, into the Chicago metro area. Its expanse included the Quad Cities and Chicago CWAs. And it was a pretty long distance, about 250 miles eclipsed from west to east. And this was a radar animation created by Matt Friedlein that just kind of gives a little bit of a perspective of this storm's evolution. You can see right now, it just traversed the Quad Cities metro, and this is it right now as it's kind of going in its different stages across northern Illinois. Now you can see it going across the northern Chicago metro and towards Lake Michigan. I'll let this play again, just so you can get an idea of the storm evolution. All right. So these things aren't really that uncommon this time of year. When we wanted to take a look at this to see, well, did this really stand out? Was this unusual? And the answer, quite simply, not really too much. These type of long-lived supercell events based off the research usually start to show up around the late spring to early summer timeframe, as you can see on the left side of the chart here, based off of Bunker's research in 2006. So this is around the early portions of the time of year where you would start to see these events. However, what was interesting based off of the research is these type of long-lived supercell events are not usually common so early in the morning. Usually you wouldn't see something like this until usually about the afternoon hours, towards about early evening, towards about midnight, generally when you have those more favorable parameters in place. So that was very interesting to see based off the research. Here's a look at that swath of severe weather. You can see all of those LSRs traversing just from about west of Muscatine, Iowa, through the Quad Cities metro, and then across northern Illinois into the Chicago metro. You can see a lot of hail reports, those greens and those triangles there all over the Quad Cities, Davenport metro are all significant hail reports. You'll see a lot of those pictures coming up here, but now we'll highlight the overall track of that with that green swath. And you can see that that follows the definition of the quasi-state rotating updraft there pretty well, the differing motions and differing directions of movement with this overall. Now we'll zoom in on the Quad Cities metro, and now you get a really interesting picture of just what each side of the Quad Cities metro experienced. A very, very different tale. The Iowa side experienced more of the significant hail side, while the Illinois side really got hammered with the tornadoes and the wind portion of the supercell. Here's a great image of what that supercell looked like just before it moved into the Quad Cities metro. So on the far left side, we've got an image of that generally over the Muscatine metro, where the storm motion in this case was more elevated, more northeast moving, where the severe weather threat was hail. As that supercell moved into the Quad Cities metro here, just as it was entering western Scott County, we started to see more of a motion towards the east. And the threat at that time was still sig hail, but as that storm did move through and become a little bit more surface-based in nature, we did see that sig wind component start moving in, along with a more of an east-southeast storm motion, just in time for that to traverse through the Quad City metro. And here are just a couple of images of that sig hail. So that one on the left was originally from a supercell that split from that parent storm that moved into the Quad Cities metro right over the Cedar Rapids area. That did produce some pretty big hail, roughly about golf ball sized hail. And then as that supercell moved into the Quad Cities metro, this is where we started to see that significant hail, upwards of about 3 inches across portions of the area. But the real big surprise, and this is what we did not initially catch, was the winds. The very quick transition towards the wind threat with this. So as the supercell entered the Quad Cities metro, there was signs of a downdraft surge becoming very evident. And about that time, we were beginning to notice that. This is when we got the 90-mile-per-hour wind gusts measured at the Moline ASOS. And that downdraft surge also spawned 4 separate tornadoes across the Illinois side of the Quad Cities metro. And here are a couple of images from those tornadoes. Different tornadoes produced these images here. The one off on the right side here was from the storm survey out in Kelowna, Illinois, and I'll show these images in here in just a second. But that was a semi-trailer that was toppled over by one of the tornadoes at the Lowe's in Moline, Illinois. Here are those sort of survey tornadoes. So generally lower end, but the one on the right side, the one over Kelowna, was the strongest one of these tornadoes. So the forecast leading up to April 4th, if any of you remember March 31st, that event, it was pretty well advertised, going pretty far out here. So, and then we saw what happened with that, with the numerous tornadoes across the area. So when we were beginning to see this pop up just ahead, or just after the March 30th event. So we were batting down the hatches once again after that significant outbreak, but the forecast was very, very good. A lot of lead time with the SPC 7-day outlook gradually trending upwards and northwards and focusing with the and focusing with the messaging. And with that messaging, we were leading up our messaging at the Davenport office as well. We began the event messaging with the SPC Outlook pretty much on April 1st, so just right after, on the heels of the March 31st event. We were focusing, though, mainly on the late day and evening time frame, when a lot of the convective allowing models were showing more of the activity. And as time went on, as we got more of an idea and a focus on where these storms were going, we began to delve more into the several rounds potential. But you can see, again, more emphasis on that late afternoon and evening time frame. Models beforehand were a little bit not in so great agreement overall. There were a couple of members of the HRF, and you can see by the paintball here on the right side, that were showing some storm development across the area, but it wasn't much. Convection overall was relatively poorly handled by the cams, and most of them didn't show activity again until later in the evening. The ones that did have the best handle, we felt, on this event, you can see that right now on the animation, was the NSSL WRF and the NAM-NES. But again, overall, the activity was mainly focused on that afternoon and evening time frame. So I will give credit for these images to Dan Bykos. He approached me as I had a poster on this during the NWA event in Kansas City, and he supplied us with these satellite imagery shots here of the goes nighttime and then the water vapor. We at the time were still trying to figure out, what exactly in the environment was causing this, and he had done some research in the past on taking a look at some gravity waves with satellite, and he was very, very eager to show us this. And we can see quite a few things just based off of this alone. I'll direct your attention first off on the left side, which is the low-level water vapor imagery here, and you can see the very warm brightness temperatures, all that red. But in that red, you can see right now there's a little bit of an area of lower brightness temperatures, which corresponds to an area of higher lapse rates, mid-level lapse rates aloft. And when you kind of see this, that was a hint of a gravity wave. And you can also kind of see this as well on the right side on the nighttime microphysics imagery. Take a look there just north of the Kansas City metro, where that area of clouds is, where that little bit of lift is, as that's moving north. You can see the convection just on the tail end of that begin to develop across south central Iowa. So right in that general area here, I'll let it play one more time, and you can see that feature moving northeast. Here's a 4-panel imagery, which gives you all of the water vapor imagery and the IR, and you can see a similar pattern, mainly across the low-level water vapor imagery. So again, you see that area of lower brightness temperatures in the darker reds, the higher brightness temperatures, right in this general area here. I'll use my mouse to point it out as this line moves across this change in density air. And you can see the convection attempting to fire pretty much along this wave as it moves across the area, which it eventually does. This is a vertical cross section also provided by Dan Bykos. And you can see this goes from Falls City, Nebraska towards Manchester, Iowa. And this gives us a nice little vertical picture of what we were seeing on the lapse rate side, as well as temperatures. And you can see, I'll let this start again here, but with time, as we go through the morning, we can see an increase in the mid-level lapse rates aloft in tandem with that wave as it's moving across the area, which further helped to strengthen the convection as it was moving into south central Iowa. I'll let this play one more time here so you can see. But take a look here at the middle portion here with that increase in lapse rates, and then the veering of winds as well with height that is associated with this feature. So going towards the morning of, so a bit of a surface analysis, we did have a warm front in place across northern Missouri in towards central Illinois. Across the Davenport CWA, winds were mainly from the east to southeast. It was a rather soupy morning and stocked with overcast, with temperatures generally in the upper 40s to low 50s with dew points in the 50s. Our morning launch at that point did confirm pretty much the same thing on the surface analysis. A pretty deep layer of moisture of RH with pretty stable lapse rates in the low levels here and pretty strong depth of the level of stable air as well. We did have effective shear of 40 knots with steeper lapse rates aloft, which played a huge role in producing all of that significant hail. But it's important to note we were still mixed within the boundary layer. That stable air was still pretty deep. As that supercell did increase in strength as it moved towards the area, we were beginning to see a lot of significant hail signatures. This was a vertical cross section of the radar. Our radar looking into that supercell just as it was over eastern Muscatine County, and you can see right around the -20 level here, those high upper 60s to low 70 dBZs being sampled aloft. And this was very important during the warning decision process here for the impact-based warning decision making with the combination as well of the environmental analysis and radar. And we were seeing this in tandem as well on Lincoln's radar just to kind of get a confirmation. And we compared this with some research for giant hail and pretty much outside of the -30 area. This fit pretty much in every other box and whisker with the research that was provided. You also had the really strong deep mesocyclone, the core in the relatively cold environment, which led to those considerable impact-based warnings. So moving on to the next one. So the hail was a given. Now, why did the wind happen? That's what originally got us with this. This is one of the assumptions. A lot of the movement of storms that morning. We figured with the movement of the northeast, conditions will be mainly favored for more elevated convection. And then the morning sounding and the surface analysis would also favor that pattern with storms remaining elevated, likely not surface based. So we were a little bit questioning of, okay, well, why did we get that significant wind? Why did the 90-mile-per-hour wind happen at the Moline Sauce, leading to all of that significant wind damage and those tornadoes? And we were diving into the research, and we didn't see much in terms of finding any mechanisms or research as to why severe winds would accompany quote-unquote elevated thunderstorms. And going back further, what we found was that 80% of nocturnal damaging wind events occurred with thunderstorms generally along or on the cool side of surface boundaries. But then, as we started to dive into more, we got into more collaboration with surrounding offices. And at the time, Brett Borkhardt at the Chicago office was starting to take a look more at this. And he was beginning to analyze thunderstorm patterns and events that had been associated with gravity waves. And we had started to take a look at this as well and seeing if this would pertain to our situation here. And you can see just some of the radar images here off on the right side taken from his research. And based off the research, we see oftentimes these wave packets often present either via radar or satellite that could cause these kinds of situations. That was similar very much to what we saw in the water vapor imagery and in that IR satellite imagery that goes nighttime. And this was also taken from the research itself. And so you can see a vertical cross section of those varying winds with height, that very strong inversion layer. In this case, the gravity wave is approaching from the north-northeast, and then that gravity wave interacts with a thunderstorm updraft and downdraft, and then rises and then sinks quickly in the descending branch, which would cause that downdraft surge, leading to sometimes those intense downbursts at the surface. And taking a look at the Moline sauce, we wanted to compare some of the data that we had seen from Brett's research, and we were seeing very, very similar findings. So one of the more important things to note, and I have here on the right side plotted, the altimeter, wind, and temperature changes. So take a look here at the altimeter, in this case, the surface pressure. So you can see right off the bat, as that cell moves right over the ASOS, a quick drop in pressure, but then a quick rise after the storm moves through. And then in tandem with that, you got the very strong wind gusts and sustained. But also take note of the temperature. So you would think typically with a thunderstorm passing through that would have had like more of a cold pool effect to it. You'd see a drop in temperature typically. But with this thunderstorm, we didn't see that. We actually saw a rise in the temperature as the storm passed. Indicating that some other mechanisms were likely in play with this, leading us more in towards the idea that the gravity wave was likely responsible for that. And what also led to that as well was that this storm did not produce much of any wind damage after it had exited the Quad Cities metro. It went back more towards a significant hail producer, leading us more towards that conclusion. This was another really interesting tool that helped us in Brett's research that also helped us lead to that conclusion. So Brett had a really nice radar animation, vertical cross section of the velocity from a storm that moved towards the La Crosse, Wisconsin radar. And you can see, I'll let this play again here, but at the beginning of the storm evolution, you can see the inbound velocities right there coming towards the radar. They're very maximized, right below an area of outbound velocity. And as the storm moves across the radar site, you can see that feature going, translating out and going out past the radar, now reflecting in the outbound. And if we go to our radar, while not quite exactly the same situation as the La Crosse area, we can see a very similar situation on the Davenport radar, where we have that maximizing of the inbound velocity at first, and then as the storm moves away from the radar, we can see more of a maximizing of the outbound velocity. So there's that feature there, right there again, pretty much showing in tandem that this was likely a gravity wave induced feature. And now, so I've highlighted the mechanisms of the storm and then the environment. So now I'm going to let Matt talk here and talk about lessons that could be learned on the messaging standpoint from this kind of an event.
Yeah, thank you, Pete. And hi, everyone. Matt Friedlein from the Davenport office. I'm the SUE here and worked with Pete, and we just lost Pete to Albany a month ago. We miss him already, as you can see with this great research he's done. As Pete mentioned early on, these types of events offer great opportunities for postmortems and to be honest with ourselves with how we possibly could have been improved as we dig into the data. We know inevitably in the Midwest, there are events that we can't always predict in advance, at least all the details of it. And I think this event still lends itself to some of that. But with some of the work that Pete done and looking at some of the research that Brett and Keith have done, I think there's some opportunities here. And so on this one slide I'm going to show, just keeping in mind the modernized forecast process as we look at messaging leading into it. And keeping in mind this is in perfect hindsight, of course, and having to be true to that and remembering that. So looking at the evening shift the night before with the idea of trying to be as much proactive and not reactive with this, thinking about the messaging that's inherited. The day shift that day had a lot of emphasis on later in the day, as Pete mentioned, the moderate risk, or at that time enhanced, but to be a moderate risk. We just had a major tornado event 4 days prior. We had the potential of that warm front that Pete showed hours later being active for surface-based supercells. That was certainly the emphasis, but the day shift had noted about the return flow overnight, potential for elevated thunderstorms there overnight, and the likelihood that there probably would be some. But going into the evening shift still, that was before the times of those satellite images that Pete showed and observational clues of what may be happening. Really difficult to say with any confidence on a severe threat and highly conditional. Conceptually recognizing, though, that on some of our bigger tornado outbreak days, which we've looked at here locally, almost always there is some morning convection. And about half those events, it's severe convection too. And I think a lot of us in the Midwest kind of know that feel on those bigger or potentially bigger supercell base days there in the afternoon and evening, you may have elevated convection in the morning, just conceptually lining up there with that idea. So there is that idea in mind. So it just drafted what a key message idea could be on the evening shift, whether it be with an AFD update or as part of a message. But it's tough to say that there'd be a severe weather threat, a definite severe weather threat the next morning, and certainly a significant severe weather threat with any confidence. And the idea of any wind for sure. And if you wanted to click forward, Pete, as we go into the mid shift here, I thought our mid shift did excellent. This is a little AFD excerpt from longtime veteran forecaster Jim Laddick here, mentioning scattered elevated supercells with large hail in the morning. This is before anything showing up on radar, and just using some of those satellite cues and especially the environmental cues that he was seeing, and that severe hail would be possible. Just a good conceptual pattern for that. So this is again a key message idea using some of the best practices from the modernized forecast process that we've seen shared here in Central Region, mentioning scattered storms, an idea on that coverage this morning, and that some may have a damaging hail threat. This isn't the perfect key message. I'm sure some things could be tweaked or adapted better, but just an idea there. And at that time, we weren't routinely doing key messages yet there. So this is kind of conceptually looking back and saying, how would we do this now if we had the same environment set up? If you want to click one more time here, Pete, looking in that early day shift, sort of in the shift transition time. Oops, my light went off here. I have a motion sensor on my light. It makes me get up. And I know some of you have seen me on webinars are probably laughing. Matt's got to turn that off. It always happens in the middle of webinars. But in the early day shift time on this event, April 4th, this is when the messaging, a more tactical messaging could happen here. And it's easier if you have the idea that the event's going to happen. If you had the knowledge on the environment, it was passed along well from shift to shift and that. And I think our mid shift had a good idea on things, but we always want to look back and see how we could improve. So this is an example of a drafted graphical nowcast that knowing everything in hindsight that we do that could have been drafted that morning. You'll see it's kind of minimized there, but gusty winds ? And that's just sort of using some of the signals and signatures that Brett and Keith have shown in their training and their research that maybe that's a threat. But I think the big thing is knowing that severe storms, supercell structures, are probable in the morning, given the environment, the satellite cues that Pete showed, our 12Z sounding that was ascending that morning, that Pete showed, huge mucate, good veering warm advection profiles, that supercell structures with at least large hail, and that SIG severe hail could be in play too. So to mention severe and some significant possibly in those more tactical messaging, whether it be Slack, social media, other type of briefings, that was definitely, I think, in play. And once that cell started to initiate that the Quad Cities Metro was in the path of that and trying to indicate that. I was at the Chicago office at that time too, and they had a little bit of the benefit of seeing the persistence of the supercell, and by that point, plural, multiple supercells in the Quad Cities area, but still a very difficult situation to predict that was going to move into the metro in the late morning, lunch hour time with major hail. That's a real difficult thing to predict there too. So this is where that tactical messaging, yet still being proactive as much as possible, using the analysis and meso-analysis and drafting messages such as this, again, idealized with hindsight in mind. And so that's what we kind of did looking back at this event here. I'll toss it back to Pete here to take it home with some key takeaways.
Sorry, I lost my mouse there. All right, let's talk about some takeaways. So evaluating the environment in full and expect the unexpected. This ties in well to what Matt said, having that meso-analysis role. And it makes me happy that the meso-analyst role during severe weather events is now being really pushed across the region. We actually utilized that utilized that position here actually at the Albany office last week when we had our severe weather and very strong winds. And we were actually doing a post-mortem here couple of days ago, talking about just how valuable that was and having that constant analysis being briefed towards the warning forecaster. This ties in towards the meso-analysis role. What possible changes to the environment are taking place? And would this lead to any potential threat changes that might, as Matt showed, need to be messaged, whether it be via maybe Slack or from a DSS builder post? I know I'm definitely going to be using this a lot more with events. Taking a look at for the presence of gravity waves. So using those satellite trends and those radar trends, seeing what Brett and Keith have used in their research, different satellite RGBs, maybe showing those density changes, those brightness temperature changes that might give those clues. Also noting changes in convective evolution. So is the storm beginning to take more of a turn? Maybe changes to the background environment. Also checking velocity data for those unique divergent couplets seen typically in elevated storms that might give a potential for some downbursts. And then last but not least, as Matt was touching on, ways to message the evening prior or prior to daybreak. In this case, for an example, the main threat remains late day tomorrow, but a heads up that any storms do develop tomorrow morning, our confidence is high they will have a severe threat. So just taking those little things into account from this. This is a really fun event to research. Like I said, it was humbling for me in that I worked the radar that morning. And it was a really great opportunity to be able to get a chance, sit down, take a look at all of these things and things now that I can utilize as I go through the rest of my career and then potentially help others. With that being said, this is the references. I want to thank Brett Borkhardt again and the folks Chicago watching for all of their contributions and help with this. And then lastly, for Dan Bykos at Sierra for providing a lot of that satellite imagery as well as the vertical cross section and analysis, which really played a humongous role in furthering my understanding of more environmental parameters to take a look at prior to these kinds of events. And then last but not least, I'll turn it over to all of you guys. Does anybody have any questions for us?
Thanks so much, Pete and Matt. If you have any questions, feel free to raise your hand or post them in the chat box and I can read them. And just to start out while everybody's thinking, I was curious. So it looks like you were able to message, especially the large hail threat ahead of time and kind of use those in your examples of what could be some key messages in the future. But Brett and Keith's paper kind of focuses on that very near term identification of those surface wind gusts and not so much from a forecast perspective. Was there anything that you, in retrospect, looked back, saw that might have helped with some of the predictability, or is it more like once you start seeing those gravity waves or once you start seeing those trends and surface observations, that's when you can start messaging that damaging wind threat?
Yeah, I can start here at least, Pete. That slide that Pete showed had some radar snapshots of some of the signatures and some of the more great applicable takeaways that Brett and Keith had there in the satellite cues that there were some gravity wave presence as well. Now, our setup didn't exactly match this perfectly in terms of the nice packets evenly spaced. There were points in there when Pete and I were looking at the radar data where it sort of mimicked that. But what also Brett and Keith had was some climatology and the time of day. This was sort of the sweet spot, getting into that overnight, into the early morning hours. Not a huge surprise when that nocturnal inversion looks like it's its strongest. The low-level jet atop is also its strongest. So knowing that background climatology, the area too, they had a climo area. We're in it, not a surprise. And then some of these signatures once storms start to initiate, but it definitely is on the more tactical end. And it's just a reminder to not discount it, and to be careful with that elevated word and what it implies, too. Just that probably that wind and tornadoes are off the table immediately. And in this setup that checks those CLIMO checklists that they had, to really be cognizant of that.
And I'll echo Matt there, especially towards the end, and that a lot of this would be more like a tactical messaging, kind of as you're seeing as you're going. This again highlights the importance of having that meso analyst position. Then maybe answer and then asking for feedback, seeing others' thoughts as well. I know definitely during this event, I had some questions on some radar images I was seeing, but there were points at times where I was wondering if that was an artifact, whether that was an whether that might have been a contamination issue. So being able to, again, having that cognizant presence, that person to bounce questions and ideas off with that meso person would be fantastic going into that tactical messaging.
Yeah, for sure. Thanks, guys. I don't see any other questions. I did see a comment from Gino in there about another case that fits kind of the profile from Pleasant Hills CWA in 2006. But I don't see any other questions. So if there are none, just thank you so much for your presentation. The recording of this will be posted shortly for anyone that wasn't able to see it and wants to look back. And that is all that we have for today. So thanks again, and thanks everyone for attending.
Thank you very much, Jenny.